In Chapter 2, we're going to go over the scientific method. So the first part of the chapter talks about the scientific method, which I find that most students are fairly familiar with because you've probably had that throughout, well, junior high and high school that you've talked about. Then we get into methods that psychologists use to study subjects, and subjects can be people or non-people. So I'm just going to highlight a few of those. Naturalistic observation, that would be when we're studying people or non-people, the subject in their natural environment. So let's say that I wanted to know how many times you picked up your cell phone during class. Well, I could do a survey and I could ask you, and I'm sure you would all say no times. How many times do you have your cell phone while you're watching this lecture? Never. But if I really wanted to know, if we were in a traditional classroom, I could have a plant or somebody like watching, and they would, mark down how many times people picked up their phone. And that would give me a much more accurate representation of how often students picked up their phone versus if I ask you, because if I ask you, chances are there'd be some bias. I mean, some of you would not want to tell me too many times. Other of you might, overestimate. I mean, there's human error when we, have to give some sort of estimate, when we're thinking about it. But if somebody's, marking down or taking notes on how many, it's going to be more accurate. So anyhow, some of the benefits. And one of the things, just by the way, when you're going through the chapter, it will give you the advantages. Here, I can just highlight real quick for you. It gives you the advantages and the disadvantages of each of the types of studies. So that's one of the things that you're going to want to pay attention to. And survey, I've already mentioned. Case study, and sometimes people get a little bit confused with this. Case study is something that we do, and it's going to be really in depth. So a survey I would give to the entire class, and I would collect back. Or if you go to Walt Disney World, if you've ever gone to Walt Disney World and you come in, or when you're leaving, they'll ask, they'll want your feedback on it. That would be a survey. A case study I might do if there was a serial killer, and I would do an in-depth study. And I'd want to talk to their second grade teacher and their neighbor and their, the people that they knew, and, gather all the information I possibly could so that perhaps I could better predict and, well, catch other serial killers. So that would be a case study. So correlational research refers to a non-experimental research method that studies the relationship between two variables with the help of statistical analysis. Correlational research does not study the effects of extraneous variables. So in other words, it does not study the impact of other things that might be involved. It only studies the impact of, two variables and whether or not we can predict if one thing happens, can we predict whether or not another thing might happen. So a correlation refers to the relationship between two variables. Correlations can be strong, they can be weak, or another way of putting it is positive or negative. And sometimes there is no correlation. There are three possible outcomes of a correlational study. It can have a positive correlation, it can have a negative correlation, or there can be no correlation. Research can present the finding, and it presents it in a numeric value, and that's called the correlational coefficient. So a positive correlation that means that both variables increase or decrease at the same time. Let me repeat that. So a positive correlation means that both variables increase or decrease at the same time. A negative correlation means that the amount of one variable, as the amount of one variable increases, the other one decreases, or vice versa. A correlational coefficient close to a -1 would be a very strong negative correlation. A correlational coefficient of a +1 would be a very strong positive correlation. Positive correlation. So if I were to say that there is a correlation of -0.75 and +0.75, that is of the same strength. Even though one is negative and one is positive, the negative and positive, all that tells us is the direction of the relationship. It does not, it's still, they're both very strong relationships. Positive means that when one variable increases, the other one is going to increase. Negative means when the amount of the one variable increases, the amount of the other variable, we're predicting it's going to decrease. And if there's no correlation, no at all would be a 0, and that, well, then there's no correlational coefficient, so 0, that's what's in between. If you have any questions about this, be sure to ask me. Your book also goes over it. I think one of the most important things to understand is that even if you have a very strong correlation, positive, negative, doesn't matter, very strong, you cannot say that one thing causes the other. And you'll hear it in the news and in social media regularly. You'll hear people say that, you know, they did some sort of study and they found that this is linked to that, and then they'll say, well, this caused that. You can't do that. You cannot say just because you found out that this is related to that, you cannot say that one thing causes the other unless you do a true experiment. And the truth is, a lot of times we cannot do a true experiment on things. A lot of times it's unethical to manipulate things in a way to do a true experiment, and that's why we have to do, you know, we have to do these types of research that, you know, correlational studies. We have to just look at to see if one thing is related to another. We can't manipulate it, which would be a true experiment. So a true experiment is defined when an experiment is conducted where an effort is made to impose control over all the variables in the study except for what we're looking at. So in this case, unlike the other ones that we've been talking about, the researchers are now going to have control, and they are going to manipulate something and then see what happens and measure something else. So let's put some names to these terms and take a look at it in a little bit more detail. So when I was in graduate school, I had to do a psychology experiment. And one of the ones that I did was I had I had a video of a woman answering questions. And the subjects would know whether or not that woman answered correctly. So in condition A, they saw the woman answer correctly. In the beginning, she answered almost all of them correct, and then at the end, she started getting them wrong. In condition B, she answered most of them incorrect in the beginning, and then at the end, she started getting them correct. Both conditions, she had the exact same number correct over the whole thing. So in both conditions, she had 60% correct. It didn't matter. All I did was change up if she had most of them right in the beginning or most of them right at the end. That was what I manipulated. Did she have them right at the beginning or right at the end? But then what I did is I asked the subjects, how smart do you think this woman is on a scale of 1 to 10? So, what is the independent variable? What did I manipulate in that study? What was different between the two groups of people? Well, in that case, what I manipulated was whether or not the woman was, the video I showed them, the woman getting them right in the beginning or the woman getting them right at the end. The dependent variable to me is always easier to figure out because the dependent is something that you measure. And in this case, I was measuring how smart they thought the woman was. It was on a scale. So if I had a scale of 1 to 10, how smart do you think she is? I can measure that. I can look at the scale, I can have the numbers, I can get an average of how smart they think she is. So that's the dependent variable. If independent and dependent variables trip you up a bit, my advice is to find the dependent first. Ask yourself, what are they measuring? And then work backwards and say, what is causing that change? What are they doing to cause that change? I find that to be an easier way of going about it. So, independent is the variable that is manipulated by the experimenters. The dependent is the variable that they are using to measure that. Couple things that we want to have in a true experiment. Obviously, there has to be manipulation. We want to have random assignment. We do not want to have the first 10 people that show up for the experiment go into one group and the second 10 go into the other group. I mean, obviously that would be biased. We also want to make sure that we are trying to control for, we're studying what we think we're studying. Trying our very best. Of course, there will be sometimes extraneous variables and other things might have an impact, but we want to try our very best to systematically minimize bias and the extraneous variables. So, main difference between correlational studies and the true experiment. The true experiment, we can say to some degree that this caused that. With the correlational studies, you cannot do that. And I'm sorry to keep pounding that home, but with correlational studies, we are saying that this variable is related to that variable, but you cannot, under any circumstances, ever say that this caused that. So, as always, the chapter has a lot more information in it. So please do read through the chapter. I do want to mention that there is information about ethics, ethics about doing experiments, ethics about using animals. So please do read through that, and there is some more information about that also in our D2L module. Please let me know if you have any questions. As always, I'm here to help and guide you. And I hope you enjoy Chapter 2.